Hi, it's me, Mr. Tokar. If you're here, you are here for your A, H, and K assessment intervention notes. This is the process we'll have to go through in order to retake a test. If you see that NY in the grade book, that means you need to retake A, H, and K values. So in order to get that retake, you must take these notes in your notebook. So take out your notebook, take out something to write with, because we are going to copy this down. So we're going to briefly review H, K, and A values, and afterwards we're going to do some practice problems, and then you'll be ready to complete the rest of the questions in this Desmos activity. So let's start off with our basic. We have our A value. Now the A value moves our graph either left or right. Left or right. Okay, the H value moves our graph either to the left or to the right. If the H value is positive, so positive H value moves our graph left. Negative H value moves us to the right. Okay? So H value, it's going to move our graph either left or right. If it's a positive number, it goes to the left. If it's a negative number, it'll move us to the right. So what does the H value look like and where does it fall? Well, it falls inside of the function. So it could look like this, x minus 2 squared. This would be our H value, negative 2, which means this graph would move negative to the right 2 units. Okay, that H value is always on the inside of the function. K value. K value either moves our graph up or down. Up or down. If it's positive, the K value moves our graph up. If the K value is negative, negative K value moves the graph down. Okay, and unlike the H value, the K value is attached to the end of the function. So if we had the quadratic function, f of x equals x squared, our K value would go to the end. So if we did the minus 2 on the end of our function, this would move us down 2. See how it's outside of the function, attached to the end, rather than being inside the function with the parentheses like H value. So K value, positive goes up, negative goes down. And one more time, H value, positive moves our graph left, negative moves our graph to the right. So our final one is the A value. Now the A value does really one of 3 things. Sometimes it does 2 at the same time. It either first stretch or compress. So the A value is either going to stretch our graph and make it look thinner and taller, or it's going to compress it, meaning it's going to shrink it and shorten it down. So when does it do what? Well, our graph is going to stretch when A is greater than 1. So if the A value is greater than 1, any number bigger than 1, 1.5, 2, 7, 25, any number greater than 1 is going to make our graph stretch. And it's like you're pulling it up like it's a Laffy Taffy. Our graph will compress when A is between, keyword, between 0 and 1. So our graph is going to compress. It's going to shorten. It's like a book is pushing down on it. when it's a number between 0 and 1. So for example, 1/2, 4/5, 0.75, 0.3, any number between 0 or 1, but not 0 or 1, is going to compress the graph. Okay, so there's one thing, two thing, there's one more thing we have to look out for, and that is if the A value has a negative sign in front. If it's negative, negative A values reflects the graph over the x-axis. Okay, so we have stretch, we have compress, and if it's negative, our graph is going to reflect, which is like flipping. So what this might look like, let's say we have f of x equals -1/2 x squared. So we still have our quadratic. Here's our a value. Our a value sits in front of our function, and it's being multiplied. So here we have -1/2 times x squared. This is an a value. The a value will either stretch or compress the graph. Because it's between 0 and 1, 1/2 is between 0 and 1, it's going to compress the graph. But we can see it's also negative, which means not only will we compress the graph, we're also going to reflect our graph over the x-axis. These are all the things you should be able to identify by looking at a graph. You should be able to tell, is it moving left or right, up or down, is it stretching or compressing, and is it going to reflect? These are all the things that could show up in any of our A, H, and K problems. So let's do a couple of problems to help us get back into the groove of things. So the first thing we're going to do, we want to identify A, H, and K for each of the following functions. So we don't need to worry about, let me drag this down. We don't have to worry about describing what's happening, but let's first talk about, okay, how can I actually find what A is, what H is, and what K is. So when I look at my function, the A value is always being multiplied in front of the function. So this 2 that's sitting right in front is my A value because it's 2 times the whole function. My H value always is inside the function. So my H value is going to be that -1. And finally, my K value is always added or subtracted to the end of the function. So my K value is going to be +3, or you could just write 3. So we've identified A, H, and K. And this function has all 3 of them. It's possible they have none of them, 1 of them, 2 of them. Sometimes they might have all 3. So let's look at our second example, A value. If I look in front of the graph, I do have a negative, which means I do have an A value because there's an invisible 1 in front of this negative sign. So my A value is -1. My H value is going to be any numbers I have inside the function. Inside of my square root function, I have a +1, so that's my H value. And my K value is going to be the number that's either added or subtracted to the end of the function. In this case, it's -1. So there's my A, H, and K value. Okay, so now that we can identify them, let's talk about what those actually mean. So we're looking at the same functions, this 2 times x minus 1 squared plus 3, and negative square root of x plus 1 minus 1. We're now going to take those 3 values we find, and we're going to describe what those will do to our function. So if we look at our A value, we had 2. And if I go up and look, 2 is greater than 1. So I know my graph is going to stretch. So my function is going to stretch. Okay? You should always ask yourself, will it reflect? In this case, it won't because it's a +2. Next, we said our H value was -1. And again, I'm going to go look. Okay, my H value was -1. Negative H value moves my graph to the right. So I know I'm going to move right 1 unit. Last one is k-value. Again, we found that in that problem right above. My k-value was positive 3, so I'm going to go up and check. Okay, positive k-value means I'm going to move up. So my graph is going to move up 3. Okay, let's do the same for our second one. We said our a value was negative 1. Well, 1 isn't greater than 1, and it's not between 0 or 1, so our graph won't stretch or compress. But because a is a negative 1, we know it's going to reflect over the x-axis. If I look at my h value, that's the one inside of my function. We said it was positive 1. I know that positive h values move my graph left. So left 1 unit. Last one, k, we said was negative 1. And again, if I went up and checked, I would see a negative k value will move my graph down 1 unit. Okay, so we've found all our values, we've described our values. Now let's take some time and let's practice actually writing an equation given in a description. So we're going to write the equation of the absolute value function. And so here we are dealing with an absolute value function. We should know what that looks like. We know it's been reflected over the x-axis. It's been compressed by a factor of 1/2. It's been moved to the right 2. And, let me get one more color. It's moved down 5. So all of these things are happening all at the same time. To figure out where to start, we need to see what kind of function we're dealing with. So we're dealing with an absolute value. So I know I'm going to start with f of x equals the absolute value of x because that's the parent function. So let's figure out, do I have an a value? Do I have an h value? And do I have a k value I need to introduce into our function? So let's start with a. I know that the graph is being compressed by a factor of 1/2 and reflected. So that sounds like it's got to be my a value. So not only is my a value going to be 1/2 because it's being compressed, I also know it's being reflected, which means it has to be a negative 1/2. So that's going to be the a value that I put in front of my function. Next, I need to figure out, okay, right 2 and down 5. I need to be able to figure out which one of these is my h value. And I know h value moves my graph left or right. So my h value has to be this right 2. If I'm moving to the right, I know my h value has to be negative. So negative 2. My k value is all that's left, and that deals with going up or down. Since I'm going down 5 units, I need my k value to be -5 or -5. Now what we're going to do is we're going to take our 3 values and put them into our function. We're going to start off with our f of x. We know the a value goes first and it's multiply, so I'm going to write -1/2 out front. I know my h value goes inside the function. So inside the absolute value with the x is going to be my -2. And then our k value always gets attached to the very end. So I'm going to do my -5 right at the end. And we have written a function that has been compressed by a factor of 1/2. It's been reflected. It's been shifted to the right 2. And it's been shifted down 5. Okay. Make sure you wrote all this down. Good luck on the questions that follow this video. There are a bunch of questions to help you practice so you're ready for your retake. Once you've completed all of the questions and you've responded to the feedback and you're all correct, you need to make sure you submit a picture of these notes as well as complete the entire Desmo's activity, and then you can schedule a time with me during an async time to retake your test and hopefully replace that NY with a grade that you want. Thanks.